Namaste children, welcome back again to this virtual class. Past two episodes we have been learning about the chapter electricity. In the first part we have introduced the concept of electric current, which is the amount of charge flowing through a particular area in a unit time. Mathematically we have seen I is equal to Q by T, the unit of current is ampere. The instrument used to measure the current in a circuit will be ammeter. So, this you always keep in mind. Next we have seen about potential difference. It is the amount of work done in carrying a unit positive charge. The unit of potential difference is volt. It is also known as voltage. You are much familiar with voltage up and down in your home, right? And in the last episode we have seen about Ohm's law. What is this Ohm's law? Can you recall? The voltage applied on a circuit is directly proportional to the current flowing through the conductor or in a circuit. This is what we have seen about Ohm's law. So, V is directly proportional to I. So, we have seen that R is a constant and this constant differs material to material. So, from this we can understand that each and every conductor can offer resistance when current flows in a circuit. In the later section of the last episode, we have seen various factors on which the resistance of the conductor depends. The first factor what we have seen was the length of the conductor. So, R is directly proportional to L. That means, resistance of the conductor is directly proportional to length of the conductor, which indicates that if length of the conductor is doubled, then the resistance will also be doubled. So, this is what we have seen, the direct relationship. Secondly, we have seen the resistance of a conductor is inversely proportional to area of cross section, which means if the area of cross section is doubled, then the resistance will be halved. If the resistance is doubled, then area of cross section should be halved, right. This way we understood how the resistance of a conductor depends on these two factors. We have also seen the resistance of a conductor depends upon the nature of the material. No two conductor will have same resistance. So, in today's session we will be looking into a new topic called resistance of a system of resistors. What is the difference between resistance and the resistor? Dear students, resistors are the components in the electric circuit which can offer resistance. Now, in the earlier case we have seen electric circuit by using circuit diagram and all, right. Now, when the current flows in a circuit through a wire, the wire itself offers some resistance. This we call it as internal resistance. Apart from this, we can increase the resistance by adding some components in the circuit. This is called the resistor. For example, in the circuit you see a bulb is there. Here bulb draws some amount of current, right. So, here bulb is considered to be a resistor. This way whatever the components which draws current from the circuit can be considered to be a resistor. The resistors in a circuit can be combined in two ways. One is the resistors can be arranged in series, they can also be arranged in parallel. Now, we will see how resistors in a circuit can be arranged in series and how the potential difference and the current changes while arranging the resistors in serial or series. We know the symbol of resistor, right? This is the symbol of resistor, usually represented by the letter R. Now, let us see how the resistors are combined in series. To combine the resistors in series, we have to put all the resistors linearly. For example, this is the first resistor, then the second resistor and the third resistor. This will be our resistor 1, R1, this is R2 and this one will be our R3, right. Now, we include in our circuit. So, this is our circuit, here applied potential difference, right. Now, here I am including a key. To know the current flowing in a circuit, we will include an ammeter. So, this is our positive terminal and this is our negative terminal. Here it is the direction of flow of electric current. In the circuit, the amount of current flowing throughout the circuit remains same. Although we have three resistors connected in series, in case of serial combination, the total current in the circuit remains constant. However, the potential difference across each resistor changes. If we connect a voltmeter across R1, then that will be the potential difference V1. If we connect voltmeter across R2, that will give you the potential difference 2, that is V2. Similarly, for resistor 3 we will get, if we connect a voltmeter across AB, then that will give you the total potential difference between the points A and B. Here the total potential difference is equal to the sum of individual potential difference across the point A and B, which means the sum of each potential difference across each individual resistor will give you the total potential difference. So total potential difference can be written as V is equal to V1 plus V2 plus V3. Now in this circuit, instead of using three resistors separately, we can have a single resistor called equivalent resistor with resistance R. So by using Ohm's law, V is the total potential difference and I is the current which remains constant in serial combination, and R is the equivalent resistance. Now by applying Ohm's law on each resistor, then we will get V1 is equal to I, which is constant. Now for R2 we can write it as V2 is equal to I R2, and similarly V3 is equal to I R3. V is equal to IR. So IR can be written as IR is equal to V1. The value of V1 will be IR1 plus IR2 plus IR3, right? Now taking common, we will get IR is equal to I as common, R1 plus R2 plus R3. Here I gets cancelled, so here we will get R is equal to R1 plus R2 plus R3. Now this is the total resistance or equivalent resistance when resistors are connected in series. Hope you understood how resistors could be connected in series. On the basis of this, let us do some most important numerical problems which are very often asked in the CBSE examinations. Let us see this numerical problem. An electric lamp whose resistance is 20 ohm. So here we have the electric lamp whose resistance is 20 ohm, right? And a conductor of 4 ohm resistance, here 4 ohm resistance is given, are connected to a 6 volt battery. So potential difference is 6 volt. Calculate the total resistance of the circuit. B, the current through the circuit, and C, the potential difference across the electric lamp and conductor. Firstly, the given quantities we will write. So this we will take it as R1 and this as R2, right? So here we have R1 is equal to 20 ohm, R2 is equal to 4 ohm. What else is given? Potential difference is there. V is equal to 6 volt, right? According to the question, first part is the total resistance we have to find, right? So here the resistors are connected in series. So R series we have to find. We know that R series is equal to sum of all the resistors present in the or connected in series. So here R1 plus R2. By substituting the values of R1 and R2, we will get R1 is 20 ohm plus R2 is 4 ohm. So we will get 20 plus 4 is 24 ohm. So this is the first part. Now we see the second, the current through the circuit. Second part is we have to find current, I we have to find. According to Ohm's law, we know that I is equal to V by R. Here we have the value of V as 6 volt and total resistance we have found out, which is 24 ohm. So here V is 6 divided by 24. We will get 1 by 4, which is equal to 0.25 ampere. Right? Second part also over. Now we see the third part. Third is the potential difference across the electric lamp and conductor. Separately we have to find out. So this will be potential difference we have to find, right? So this will be our V1, this will be our V2. So this we have to find. So firstly we will find V1. So V1 is equal to I R1. So by substituting the values, V1 is equal to, I is a constant which is 0.25 multiplied by R1 is 20 ohm, right? So 20 ohm. So upon solving this, we will get 5 volt. So now we find for V2. V2 is equal to I R2. So I is constant term. I is 0.25 ampere multiplied by R2 is 4 ohm, which is equal to 1 ampere. How easy, right? By knowing the formula of Ohm's law and formula for finding total resistance in serial combination, we can simply solve the numerical problem. Let us see another numerical problem. Now look at this question. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor and a plug key, all connected in series. It is schematic diagram. You have to make a circuit diagram. How to make this circuit diagram, we will see. We will start from potential difference, that is 2 volt potential difference. Here in the question it is given that 2 volt each, 3 cells are being used, in which each cell is 2 volt. So here we make 1 cell, 2 cell and 3 cell. Over. Now 3 resistors all connected in series, right? So here we will make first resistor, then second resistor, then this is our third resistor. So 3 resistors over here, R1, R2, R3. R1 has the value, R1 have the value 5 ohm, R2 with 8 ohm, R3 with 12 ohm. Over. Then what else is to be drawn? A plug key we have to make. So here plug key we will make here. This is our plug key. This will be connected to our circuit. So this is our positive terminal, this is our negative terminal, this will be the direction of the electric current. You see here 3 cells of 2 volt each. So altogether we will get 2 into 3, so 6 volt. So here we can write it as 6 volt. So this way circuit diagram can be made with the available components. Hope you understood the numerical problems. Likewise, you can practice more such numerical problems. Have a grip on such type of numerical problems so that you will find it very easy when such type of question comes in the CBSE examination. So now we will see how the resistors could be connected in parallel. Let us now learn how the resistors are connected in parallel. So here I am making the first resistor, here I am having the second resistor, here I am having the third resistor. Now you see all the resistors are arranged in parallel, right? They are parallel to one another. Now from this you can make parallel arrangement like this, and let us have our circuit. Let us see how we can have these resistors parallel arrangements in our circuit. Now this is our potential difference. We will have a key and we will have an ammeter to know the current, right? And also we assume that this is point A and this is our point B. So across the point A and B we will have a voltmeter to know the potential difference. So this is our positive terminal and this is negative terminal, this is our key. The direction of flow of electric current will be this, right? Here we write it R1, this will be our R2 and this will be our R3, right? In a circuit containing the parallel combination of resistors, it is observed that the total current is equal to the sum of the currents through each branch of the combination. If you connect ammeter here, then the value of current will be different. If you connect it here, then the value will be different, and if you connect over here, then the reading shows different. If you find the total current in the circuit, then it is seen that it is the sum of the total current across each branch of the combination. Let us find out how to find the total resistance in a system of resistors in parallel combination. Now from this we know that I is equal to I1 plus I2 plus I3. and we know that I is equal to V by R. Here R is the resistors in parallel, we write it Rp. By applying Ohm's law across each resistor, then we will get I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So we know that I is equal to the sum of all the currents I1 plus I2 plus I3, and I is equal to V by Rp. So we can write V by Rp is equal to I1. The value of I1 is V by R1 plus V by R2 plus V by R3. So by taking common, we will get V by Rp is equal to V as common, so we will get 1 by R1 plus 1 by R2 plus 1 by R3. So here V gets cancelled, so 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So when the resistors are combined in parallel, then the total resistance or the equivalent resistance of a circuit can be found out by using the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Hope you understood how the resistors are connected in parallel. So based on this, let us do some numerical problems. Look at the numerical problem. In the below figure, that is this figure, R1 is 10 ohm, here this one is 10 ohm, R2 is 40 ohm, R2 will be 40 ohm, R3 is 30 ohm, this we will write it as 30 ohm, R4 is 20 ohm, so this is 20 ohm, and R5 is 60 ohm, and a 12 volt battery, so potential difference is 12 volt connected to the arrangement. So arrangement of the resistors are as per the figure. Calculate A, the total resistance in the circuit. We have to find total resistance in the circuit, and B, the total current flowing in the circuit. In this circuit, we find two different types of arrangements. One is R1 and R2 are arranged parallel. Similarly, R3, R4 and R5 are arranged in parallel. But R1, R2 and R3, R4 and R5 together they are in serial combination. Once we find the resistance of these parallel combinations, then we can easily find the resistance in serial combination. Let us find the parallel combination first. Firstly, we write the given quantities. R1 is equal to 10 ohm, R2 is equal to 40 ohm. With this we can find the first parallel combination, right? So 1 by R parallel 1 is equal to 1 by 10 plus 1 by 40, right, which is equal to, by taking LCM and all, we will get 5 by 40, right. So here 1 by Rp1 is equal to 5 by 40. So Rp1 would be 40 by 5. 5 ones are 5, 5 8s are 40. So this will be 8 ohm, right. Now secondly, parallel 2 we have to find. This is our Rp1, right. Now we have to find this one. This we take it as Rp2. For this, the given values we write R3 is equal to 30 ohm, R4 is equal to 20 ohm, and R5 is equal to 60 ohm, right. So here 1 by Rp2 is equal to 1 by R3 plus 1 by R4 plus 1 by R5. Got it? So substitute the values, we will get 1 by 30 plus 1 by 20 plus 1 by 60. Upon taking LCM and solving, we will get 6 by 60. So here Rp2 will be 60 by 6. Solving this, we will get 10 ohm. So now we have got the entire value of Rp1 as 8 ohm and Rp2 as 10 ohm. Here in the circuit, Rp1 and Rp2 are in serial combination. So we have to find resistance in serial combination. So how can we do? Here R series is equal to Rp1 plus Rp2. So knowing the value, Rp1 is 8 ohm plus Rp2 is 10 ohm. So finally we will get 18 ohm is the total resistance, we can say RS or R total. So total resistance in the circuit will be 18 ohm. Now we have to find the current, that is our second part. So this is our first part got over. Now the second part, the total current flowing in the circuit. We know that I is equal to V by R. So potential difference is given as 12 volt. So 12 divided by resistance, just now we have found out 18 ohm, this is volt. Upon solving this, we will get 2 6 are 12, 3 6 are. Finally we will get 0.67 ampere. Got it, children? How can three resistors of resistances 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm, and the second part is 1 ohm. Also draw the circuit diagram. Before going to solve this numerical problem, you should know some of the basic things. What are those basic things? Suppose we are having two resistors, one is of 3 ohm and another one is 4 ohm, right? If we want to increase the resistance, then we have to combine the resistors serially. So serial combination we have to do. If we want to decrease the total resistance, then we have to combine in parallel fashion. If we combine the available resistors parallelly, then the total resistance of the circuit would be less than that of the resistors having lesser resistance, that is 3. So our total resistance would be less than 3 ohm. If we combine 3 ohm and 4 ohm serially, then the total resistance would be greater than the resistor with greater resistance. Here the total resistance would be greater than 4 ohm. Having this idea, let us solve this numerical problem. So in the question it is given that first we have to find 4 ohm. What are the resistors available that we write? We have 2 ohm resistor, 3 ohm resistor and 6 ohm resistor. We have to combine these resistors in our circuit in such a way that the total resistance of the circuit would be 4 ohm. Now can we do serial combination? Either of the serial combination will not get 4 ohm, because if we combine 2 ohm and 3 ohm serially, then we will be getting 5 ohm. So other resistors are higher value. So by serial combination we won't be getting 4 ohm. So what option is left here? Here we can combine all the resistors or some of the resistors parallelly. Now we know that if we combine the resistors parallelly, then the total resistance would be less than the resistor with lower resistance. So here if we combine all the resistors, then our total resistance would be less than 2 ohm, right? So excluding 2, let us try. If we combine 3 ohm and 6 ohm, then our value will be less than 3. If we get less than 3, then another combination we can do, that is with the 2 we can add. So let us try with parallel combination between 3 ohm and 6 ohm. Initially 1 by R parallel between 3 ohm. So 1 by 3 plus 1 by 6. Here solving this, LCM of this is 6. So here 2 3s are 6, here 1. So we are getting 3 by 6, right? So Rp is equal to 6 by 3. So here getting 2 ohm. You see here, after combining 3 ohm and 6 ohm parallelly, we got 2 ohm. Actually we need 4 ohm. What can be done now? Now we already have 2 ohm resistor, right? By combining these combination, that is 1 by 3 plus 1 by 6, again we can combine it with serially with 2 ohm resistor, right? So here once again Rs is equal to, what can we do? Here 2 ohm resistance plus the resistance of parallel, so Rp. So upon solving this, we will get 2 ohm plus 2 ohm, we will get 4 ohm. Got it, children? Now we have to make the circuit diagram. So for making circuit diagram, first parallel combination we will make. So here we add the first resistor, this is our second resistor, they are in parallel, and after this we have to combine it with another resistor serially, right? So here is our potential difference, here are parallel combination. So this is the circuit diagram, this is positive terminal, negative terminal, this is the direction of electric current. Here the first resistor will have the resistance of 3 ohm, this is 6 ohm and this will be 2 ohm. So this way, by combining 3 ohm resistor and 6 ohm resistor parallelly, and then these are combined serially with 2 ohm, we will get total resistance as 4 ohm. Got it, children? Now we solve the second problem. See here, in the second part we need to find 1 ohm. The total resistance would be 1 ohm, right? For solving second part, we cannot combine the resistors serially because the lowest resistor have the value 2 ohm. If we combine anything, then it will be greater than 2, right? We need less than 2, that is 1 we need. So let us try with all these resistors are combined in parallel, what we get. Only by parallel combination we may get 1 ohm. Let us first see how it could be done. Let us see whether on combining all these resistors parallelly, whether we get 1 ohm or not. So here 1 by R parallel is equal to 1 by the first resistor, that is 2 ohm, plus 1 by 3 ohm plus 1 by 6 ohm. So upon taking LCM we will get 2, 3, 6, 6 is our LCM. So 3 2s are 6, 2 3s are 6 plus 1. We are getting here 6 by 6. So here Rp is equal to again 6 by 6. Solving this we will get 1 ohm, right? So straight away by combining all the 3 resistors parallelly we are getting 1 ohm. So how can we draw the circuit diagram? Very simple, right? So for making circuit diagram we have 3 resistors, all the resistors are combined parallelly, right? So this is second resistor and this will be R, third resistors, all the resistors are combined parallelly, right? So here is our potential difference. So this will be parallel combination. Then finally, so this is our positive terminal, this is negative terminal, this is direction of flow of electric current. Now here we have to write the value. Here we write 2 ohm, this is our 3 ohm and this is our 6 ohm. So when we combine all these 3 resistors parallelly, then the total resistance we get is 1 ohm. Alright, children? Hope you understood the numerical problems. Likewise, you can practice more such problems. So dear students, that's all we have for today. Before concluding this video, I would like to give some easy home assignments which you can practice at home. Here is your home assignment. Dear students, I believe you will find all these home assignments very easy. See you all on another day with a new topic. Till then, take good care of yourself. Bye.